at Gravity, which is an open source platform for API and access management. So as I just kind of went through, the agenda of this session is to first define what API security is. We will then give some insights into some of the research around API security and what organizations are doing and what are challenges with this theme. We will then be looking at a matrix where we look at some API security measures and approaches and how convenient they are for customers, because obviously we live in a world where customer experience is becoming more and more important. And maybe you should even think about the terminology of security experience. You know, how can we make it as easy and safe for our consumers and users as possible? Then I'll show a couple of hands-on demonstration examples for how we can implement some of the measures that we have talked about, how we can make sure that our customers and our users and consumers are being protected, but also making their life much easier in terms of managing their credentials and managing their kind of authentication and authorization journey. We'll wrap it up with some recommendations and thinking points before we go over to a Q&A. But obviously, feel free to ping questions throughout the session, and I think Juliet will stop me and we'll try to answer the questions as we go as well. So to start with, what is not best but providing a definition by Gartner. So API security typically consists of what is called API protection and API access control. So what are the differences between API protection and API access control? So typically in API protection, you talk about how can I protect the content and the traffic that comes in through the request and response for a particular request. So that could be validating the content, making sure that there are no kind of injections, or maybe the message is small enough for the backend to handle it. It could be looking at the IP address that the message is coming from to making sure that it's from a trusted source, or maybe just about protecting the infrastructure and the backend, for example, by enforcing a quota or traffic throttling. Some typical categories of products here, web application firewalls, DDoS threat protection, API management, of course, and also application delivery controllers. Now, the difference with access control is that is more about how a consumer will authenticate and get authorization to various resources and different endpoints within the environment. So here we talk about, for example, OAuth 2. So how can we use existing frameworks to allow users to authenticate and get access to different protected resources? How can we use JSON Web Tokens, for example, to validate the message, as well as extracting some user information that might be required in order to fetch the right data from the backend? So again, API management and different access management softwares come into here, as well as different identity providers and identity as a service. So now when we define what API security is, let's talk about why this is such a big topic at the moment. So I'm gonna just highlighting two external research reports here. The left one is from the State of the API Economy 2021 report by Google, where they've asked different Google customers, what are the changes around APIs that you're looking to do within the next 12 months? And as we can see in the top left corner here, the number one priority basically is to be focused on API security and API governance. If you look on the right-hand side, this is a report through Vance and Bourne, also 2021, about the APIs and integration space for this year. And for the organizations that were asked the question, which is the following challenge that you face when utilizing APIs, 48% said that it's about ensuring API security. So how can I protect the APIs that I'm exposing? And how can I also make sure that my consumers that are using the APIs are protected and secured in the correct way? Okay, so I wanted to spend a little bit of time on this because, as I mentioned, customer experience is more and more important for every day. And as we are, seeing more and more attacks and breaches in various systems, but also consumers having to deal with more and more passwords and different types of authentication protocols and devices, obviously the consumers are faced and the users are faced with more and more challenges in terms of how they communicate with our applications. So what I've done here is I've basically taken some of the trending or existing measures of securing or protecting both the access to your APIs, but also how you would protect the traffic and the messages for those requests and responses. So, and what I've done here is I basically created a matrix where on the left axis here, that goes from the top to bottom, we have the convenience. So how easy is it both for an organization that is implementing these measures, but also for the consumers themselves? So as an example, on the bottom left here, we can see basic authentication. So basic authentication is typically when a user or an application need to provide a username and a password in order for the backend service to authenticate and give access to the resource that they are calling. Now, basic authentication obviously has been around for a long while. It's probably not going to go away for a long while either. Obviously, there are two challenges with basic authentication. One is that it puts a lot of stress on the user, on the consumer, to make sure that they manage the username and password in a secure way, that it might be stored in a manner that no one else can reach it. And it's also, a very big and challenging task for the backend implementation and the actual provider of the service to obviously both validate that the credentials are the right ones, that the user is who they're saying that they are, but also to rotate these kind of credentials. Maybe you would apply things like a password expiration or different types of password controls to make sure that it's as safe as possible. So it's not very convenient for the user, and it's not that safe because we've obviously seen many times that when you have APIs that are being accessed by this type of authentication scheme, it's quite common that those credentials are visible in plain text and not rotated properly. If you look at an example of a more of a protection type of measure like IP filtering. Now, IP filtering used to be kind of the go-to way for organizations to make sure that their APIs was only accessed by users within the network, for example. But as with basic authentication, it's not the most dynamic approach, and it puts a lot of stress on a network team to make sure that the ranges of IP addresses are up to date. There's obviously the concept of different proxies and different VPNs that could kind of, in some cases, bypass and kind of transform the source IP that they are calling from. API key is, well, probably with basic authentication, currently the most common and most used type of authentication mechanism for API calls today, especially for server-to-server type of communication. So an API key is typically a key that is unique to you as the consumer, that you are maybe sharing with your organization or with your other kind of colleagues, but it should be something that is unique to you as a consumer application of that backend resource. It's something that is typically given on almost a lifetime basis. There are measures to rotate that API key and for a backend to basically rotate them for you and set an expiry for those API keys. But again, it's something that is quite difficult to implement. And I know there's a lot of organizations today that have relationship with partners that need to utilize their APIs, where you would be able to send out an email, for example, hey, Mr. Partner, here's your API key that is unique to you and only you. Please keep this one protected, and this is what you're going to be used to authenticate to the APIs. Obviously, it would be very easy for that partner to just share that key with someone else. And also, it's obviously a risk in terms of someone abusing that partner's key and making requests that are not actually authorized by that partner. Now, threat detection is another measure which falls in the kind of the protect phase here. So this is about how can you, as API gateway or as the backend, look at the incoming request, whether it's about the headers or whether it's about the actual content itself, and apply some smart rules to say that, hey, actually, I'm not going to let this message through because it's too big, or it has some injections in it, or some other unsafe operations or data that I'm not going to let in. Typically quite easy to implement. It's not something typically that a consumer is going to be challenged with, because it's typically implemented purely on the backend layer. But again, not that secure, because it still means that you will get access to the information from the response, and this is more about protecting the backend server, basically. Now, another very common measure of protecting your backend services is throttling. So some of you may know this by rate limiting, or quotas, or spike arrests. There's multiple types of throttling incoming data. You could do it based on the user, their IP address, or maybe just the number of requests that is currently coming in towards your backend API. So throttling is about controlling the number or the rate of the request that comes in, to protect from attacks and distributed attacks, and also for people that is trying to abuse your service. Now, in the middle here, we have OAuth 2 and OpenID Connect. Now, OAuth 2 is naturally a standard that can be implemented in a lot of different ways. That's kind of why this is here right in the middle, because it really depends on how the implementation is being done. There's multiple grant types with OAuth 2, of course. Some is actually using a password or basic credentials in the flow, which means that it's not that much more secure than basic authentication. There's obviously kind of a server-to-server type of flow for client credentials, where again you have to make sure that you keep your various credentials not in plain text and only within your organization. But there's also other flows that we will be looking at in the demonstration later, that uses, for example, a authorization code flow, where we're using an existing resource provider to give you access to a resource. Then we have on the bottom here, we have HTTP signature and encryption and data masking. So HTTP signature is basically for a consumer to provide a signature that is calculated based on some of the data in the request, might be the content or some of the headers, with a specific key. It could be a symmetric key or an asymmetric key agreed with the client and the backend, where then the server can validate that yes, this request is actually coming from the user that sent it, based on the symmetric or asymmetric key that has been agreed. And then encryption and data masking is obviously about the more or less the backend protecting the client for the data to be transmitted in plain text, or if there's sensitive data on the backend, to protect that data before it's returned to the consumer. Could be, for example, to remove sensitive information, PII data about maybe addresses or contact information for different people, if it's a resource about employees, for example. So we look on the top right screen, we have SSO. So SSO is quite convenient for a user. Typically, it means that the user do not have to have any new credentials to keep track of. SSO obviously stands for single sign-on, and typically when users and organizations are implementing single sign-on, it's to have users keeping track of less passwords and less credentials, to make it easier for the customer and the consumer, but also to make it more secure, of course, to not have them saving down multiple credentials, for example, in different files. Passwordless and web off is, see, I made a spelling mistake here, is basically a way for consumers to authenticate to applications without having to input any text, for example. So it could be biometrics devices, it could be your Face ID. I'm sure a lot of you have if you have a somewhat modern mobile phone, you probably unlocked your screen with your Face ID, or maybe your fingerprint, or other types of biometrics. So again, this is a way to avoid people having credentials that can easily be exposed or forgotten or written down in unsafe places. So very convenient for the user, and it's quite secure. Now, if we go all the way to the bottom right here, we have certificates. So certificates is basically a way for both the client and server to decide on, for example, it could be a mutual TLS type of of communication that is very popular in open banking, for example, to make sure that we have already agreed on the keys that we are going to be using, or the certificates we're going to be using when we have the communication between the client and server. So there's a bi-directional agreement on that. We both say who we are, who we say we are. Not very convenient, because it's a quite difficult thing to rotate. Obviously, especially for a client, you wouldn't trust some developer to sign up for an integration that they want to try out by requesting an API to submit their own certificates, or to download certificates and make them valid in the browser, etc. It's quite a tricky thing to manage for both a client and a server, but it's definitely very secure. A bit on the top left of certificates, I have MFA. So MFA stands for multi-factor authentication. This is a way to apply additional means or layers of authentication on top of passwords or on top of other types of protocols. So this could, for example, be when you receive a text message or an email, or maybe something on your Google Authenticator application when you're signing into a software, to make sure that you not only have access to the credentials, but you also have access to a physical device that makes it more secure to say who you are, to kind of prove that you are who you say you are. And then we have intelligent MFA, which is quite an interesting, it's also called context-aware MFA. So this is a way to increase the convenience by either not having to request for this other layer of authentication if you, in the request, already trust the user based on the request. It could be that they have a trusted device, for example, that they've already used a couple of times, and you are quite confident as the backend that they are not compromised. Or it could be related to saying that, hey, you're now signing in from another country that you're typically in. Because of this, we're not going to give you the full scope or access to the same resource that you typically have. So that's an example of intelligent MFA. So I just wanted to stop there, Julia, to give you a chance if there's any questions that are coming in through the chat or anywhere else, if you'd like to kind of feed them in. Otherwise, obviously, I'll keep going. Doesn't seem like there is, so I'll keep going. What I'll do now is I'll go through a demonstration. So the idea of this demonstration is to show you some examples of what we just covered. So we're going to show some example of how we can apply protect measures, so throttling, IP filtering, rate limiting, etc. And we also go through how we can manage. So if we really need to manage API keys, how would we do that? How can we kind of set expiration on API keys that are given to applications? And how can we combine that with some other protection measures? For example, like IP filtering, making sure that only API keys that are being used within your protected network is allowed to communicate with your backends. And then we're going to move to some, let's say, more modern approaches using different OAuth2 authorization grants. So we're going to be using WebAuth. So I'm actually going to be using the fingerprint on my laptop. And I'm also going to be actually combining that with a Google Authenticator on my mobile device. So I'm actually going to be using two devices to authenticate to my application so that I can use the APIs. And I'm going to be using both my laptop and my mobile phone. Okay, so let's get started rather. What I'm going to be doing is I'm going to be sharing my browser here. So what I've done, remember here we have three different things we want to show. We want to show how can we have something accessible to everyone, yet still protecting that through some API protection measures like throttling and rate limiting. And then how can we actually have a partner going and requesting an API key in a secure way that includes an approval process and an expiration, as well as a combination with some other protection measures. So what I've done here in the API management stack is I basically set up an API here called a time API. Now this time API is a very, very simple API. It's called, if I do /time on the gateway, and the service that it's going to be invoking is this very, very simple backend right here. Just returns a JSON structure with the current time and the current date. I can just refresh it right here and you're going to see that it's going to be keep changing. So the idea is I want to protect this backend service in different ways. So that's why I've created this API here called the time API that is accessible on this /time entry point on my API gateway. So I can just go here to my gateway. I can refresh the screen here, but you see that there's a difference between going to the actual backend server and going to the API. So when I go to the API here on the gateway, it's actually telling me that there's no date to display for this free plan. So what does a plan mean? So if I just go back in here into the portal and into the plans, we can see we have created 3 different plans. So I created one that I call free. So this means that people using this plan does not have to authenticate in any way. It's publicly available, just as we just indicated here, by going to the gateway and just refreshing it. Naturally, it's running on my local host, but the same would apply if you would be exposing it on a public domain. Then I have the internal one, which is based on an API key authentication. So that means that users using this plan needs to provide an API key in order to authenticate the request and to actually get access to the backend. And then finally, we have an OAuth 2 plan that will give us unlimited access to our API. And this is basically intended for a web application or maybe a mobile application, so that users can sign in using maybe a single sign-on capability, or using an identity provider like Salesforce or Azure or Active Directory, whatever it might be. Okay, so what I've done here is I've designed my API to respond differently based on what type of security is being used. So if I go to the free one here, you can see I'm using something called a mock policy. This is basically saying that actually we're not going to return what is on the backend. Instead, we're going to return this mock response right here. So we're actually not going all the way here to the backend when we hit the API using this anonymous plan. Instead, we're going and returning this mock response. So this is just an example of how we can actually allow our API to be used by anyone without any authentication, but we're controlling, in this case, that the user is only getting an example data back and actually not hitting our backend service. And in my case, the reason for that is just the fact that I want to be able to maybe allow people to build a mobile application towards this application, but they're not actually getting access to the right data. Okay, so what also I've done here, as you might have seen, I've added a rate limit policy. So this is a throttling mechanism that would allow me to say, for example, if you're using this without any authentication, if you're using this kind of free plan, you're only allowed 5 requests per minute. So if I go back here to my gateway and I keep refreshing this a couple of times here, so that would be 5. So now if I try it more, we can see here that it says, hey, rate limit exceeded, you reach a limit of 5 requests per minute. So that would mean that we're, in this case, obviously we did not go to the backend because we returned that mock response. But the concept here is that you can very easily then protect your backend by returning this type of error message to the user if there's already too many requests being made, whether it's in general or for those users through their applications or IP specifically. Okay, so that's the first thing. Now, as I mentioned, we wanted to have some more layer of security, and in my case here, I'm using an API key for consumers to authenticate themselves. Now, if I go into that one, you can see that I'm not using any mock response, which means that people using an API key will be moving towards the backend to actually get the real data in the backend service. However, we will apply IP filtering. So we're going to say that only users within the internal network are allowed using an API key to use this type of plan. Now, obviously, I mentioned that API keys are not very secure, and it's quite difficult to manage. Now, if you have requirements to manage API keys anyway, what you typically would do is you would typically have a way, for instance, for your partners, for your customers to display and find your different APIs. So in my case, I might go here to a developer portal. I might find the API as a partner that I want to subscribe to. I can, of course, see the URL of that one, but I can also see the different plans it has, right? So here we see the free one, we see the OAuth 2 one, and in my case, I can subscribe to the one that requires an API key. So I'm going to say, okay, this one requires manual validation. That basically means that the API owner or the manager of the API needs to approve me as a partner before I get access to the key. Maybe I need to accept something. Maybe there's a cost associated with it, or maybe I just need to provide a good justification of why I want to use this API. And I'm going to get this personal key that allows me to use this key when I have called the API to authenticate. So I'm going to select an application here that I've already decided that I wanted to use. So this is an application, is basically the identity of a consumer. And here I'm just going to say, please accept me. Okay, so what happens now is that as an API manager, I'll get a notification here that says that, hey, this application, internal network application, wants to subscribe to this time API using the internal API key. So I'm going to say, yes, that's a good justification. I'm going to accept you, but I'm not going to just give you a key and let you run with that key forever. I'm actually going to say that this particular key is only valid for actually 2 days, effectively, or 3 days inclusive. And then you need to get another key so that if your previous key gets lost or it gets stolen by someone, at least they cannot abuse your access of it. Okay, so as a user, I would then be able to see the status, of course, of my different subscriptions. So in this case, I have an accepted subscription. I can use this API key. And rather than going here in the browser, I'm going to be using Postman in this case, just to put in, and I can try here if I just call the API, the time API. Again, it's saying no date for free plan. And again, I'm expecting here to see that it's going to be telling me that I've exceeded rate limits. But if I add that API key right there, I try that again. Now, of course, it's telling me instead that my IP address is not allowed. So just to kind of demonstrate how I could, finally get a call working here, I could just go in here and replace this IP address range here with localhost, for example, just to kind of try out how it will look like if we actually talk to the backend through this gateway with this API key. So now if I go in here again and I make a new call, now we can see that we're actually getting, real life calls from responses rather from the actual backend. Okay, so that's the API key. Now what we can do, of course, is we can revoke that key, we can cancel the subscription, we can control the access that particular partner that I just represented has on that API. So I can go into their application, I can revoke their access entirely, I can give them a new key, I can revoke the key, I can change the expiration, etc. Okay, so let's take another use case here. So let's say that we are providing an application for our users. I'm going to open up here a web applications that I built. This web application gives me the ability to call an API just by clicking on a button effectively. Now, if I just do this here, if I click this, we're going to say that it says loading, and then it says again, no date for free plan, because I'm still making an anonymous call here. This browser is just as we did here, it's just making a call. So if I do this a couple of times, it's obviously going to say that I've exceeded the rate limit and I'm not allowed to do any more calls. So what I need to do is I need to be able to sign in. So now we get a server error down here. I want to sign in and authenticate as a consumer, as a user, an end user here. I don't know what type of security measures are in place or what the actual plans, etc. look like. I just want access to my data. So the way I've set this up is I've created this app here to have a sign-in button. And if I click that, I'm getting a kind of authentication dialog here. Now I can put in my basic credentials. I'm not going to do that because in this case, I don't want to use my basic credentials. I can use single sign-on, maybe with Google, for example, or as I mentioned, Active Directory or Salesforce, wherever it might be. But in my case, I'm going to be using the WebAuthn protocol and the fingerprint capability in this case. I'm going to say that I want to sign in with fingerprint. I'm going to type in Alice, which is my username, and then I'm going to be typing in, or not typing in, rather using my fingerprint here to move to the next stage. And remember, we said that we actually going to do multiple factor authentication as well. So I need to provide here the current code in my Google Authenticator application that I have on my mobile phone. Obviously, I'm not sharing that screen. However, I've just looked at my mobile phone right now to do that. And now we can see here that I'm signed in as Alice. So now when I press Time API, what I'm expecting is to actually get the proper backend server and response message here. So I'm actually now able to use that OAuth2 plan. So just to give you a glimpse of how that worked. So if I go into my platform here, if I just go into my API again, so we mentioned, of course, that we had those 3 plans. So we had the free one, which we can use as much as we want, well, at least 5 times in a minute, but anyone can use it rather, but you're not getting to the back end. We can use the API key, but it requires the partner or the consumer to subscribe and ask to be subscribing to get that individual key. It will allow them to call the API if they're in the right IP address, and they will get through to the backend. And then we just look through the OAuth 2 plan that allows, for example, web applications to allow their end users to authenticate with single sign-on, or in my case, with fingerprint using maybe an existing identity provider. Maybe that identity sits in an Active Directory somewhere, or an LDAP, or whatever it might be. So just to give an idea of how I configured that. So obviously I gave it a name and a description. And then here I gave it what is called an OAuth 2 resource. And the OAuth 2 resource here is the access management capability. So here I just created an application that holds those client ID and client secrets that are being used by OAuth to authenticate the user effectively. So what I've done here is I've obviously set up a OAuth 2 types of flow. So I've set up that, okay, using this application, you're allowed maybe as a web app to use the authorization code flow or the implicit or the refresh token, but I'm not allowing you to use password or client credentials or UMA ticket. What I've also said is for applications using this application, they need to have a multi-factor. So here I've set up that I want a multi-factor using a custom, in my case, Google Authenticator. And what I'm also saying here under login is I'm saying that, okay, I'm going to allow also users to be using passwordless means of authenticating. Okay, so what I can do as well here is, of course, is I can go into my application. I can look at the analytics to see that how are people actually logging in. So, we've logged in a couple of times here in the morning, and we just logged in right now a couple of minutes ago. And then I can, of course, also see the actual identity providers that Alice in this case sits in. So in this case, it might be Google, or it might be a MongoDB database. As I mentioned, this could be anything, any type of identity provider that you can imagine. So that's just a glimpse of some of the different levels, let's say, of authentication that we can apply on our API. So if I just go in here and kind of share the last slide here before I open up for the Q&A. So if you need to use basic credentials and username and passwords, try to have an SSO so that your consumers do not have to add another list of usernames and passwords to manage. And if you have to use API keys, at least let's see if you can have some way of rotating and managing the access to those API keys, as well as the expiration of them, to make sure that your partners are protected, or whatever types of consumers that you might have to your services, whether it's internal or external. And as we just shown, if you're using API keys, you should potentially think about only exposing those API keys within your network. So for example, to protect that API through IP filtering, making sure that only users in the specific areas or departments or networks that you want to have access. And that you can use very simple measures like rate limiting and threat protection, etc., to add that extra level of protection on the data that goes back and forth to your systems. And as we've kind of introduced in the beginning, as the consumers are using more and more applications, as customer experience are becoming more and more important for how organizations produce services, we need to start thinking about how we can make security convenient for our customers and consumers, not only how we can do them more secure. Naturally, there needs to be technologies like biometrics, like intelligent MFA, through protocols like OAuth 2 and OpenID Connect, for example, that allows applications to be created that delivers both security, but also convenience for how it's being managed by both the backend team, but also for the consumers themselves as they manage their credentials. Here's an example of a UK-based bank, Tide. When their customers are getting access to their bank balances, etc., obviously that is through APIs, but to actually authenticate to those APIs, they use biometrics, for example, their fingerprint to actually make the request to the APIs. So I think that's it. I think we have quite a few minutes for Q&A. So I'd like to thank you all for watching before we go into the Q&A. I have highlighted some links here So you can reach out to me, connect to me, tweet me, or check out Gravity and the open source technologies that we do.